Today we're going to look at how to find an unknown angle using Trigs. Before we get into the actual calculation, let's just recall a few things about what we know on Trigs. So firstly, let us label this right angle triangle. Now in any right angle triangle, the side that is opposite to the right angle is your hypotenuse. So this is the hypotenuse. Now the other two sides in the right angle triangle are the opposite and the adjacent sides, but these are named according to where your angle of interest is. So if I put my angle of interest here, let's call that angle theta. Then the side that is opposite to that angle, that would be your opposite side. And then the side that is adjacent to that angle will be the adjacent. But really and truly, if you have the hypotenuse and the opposite, then there are only three sides in a triangle. So the third side must be your adjacent side. Adjacent means next to. So as you can see, the adjacent side is next to the angle of interest. And the angle of interest is bordered by the adjacent and the hypotenuse. Right? So however you want to remember these sides, it's up to you. But it is important that you label the right angle triangle correctly because if you don't, you're going to end up using the wrong ratio. So let's look at the different ratios now. The first ratio, the sine of an angle, abbreviated as the sine. So sine of the angle theta is given as the ratio of the opposite to the hypotenuse. The cos or cosine of an angle, so the cosine of an angle is abbreviated as cos. Cos theta is the adjacent over the hypotenuse. And then finally, the tangent of an angle, tan of theta, is equal to the opposite over the adjacent. And this is how we come up with the acronym SO, CA, TOA, right? So is sine opposite hypotenuse, CA cosine adjacent hypotenuse, and then tangent opposite and adjacent. So that's where we got SOCA TOA from. So let us look at an example. I'm gonna just sketch a quick right angle triangle here for you, and we're gonna find the angle. It's not perfect, but I wanted to use the ruler. All right. So that's my right angle triangle there. All right, let me identify my right angle. Here it is. Cool. And this is my angle of interest, theta, which I want to find. So find the angle theta. Well, let's say this side is 3 centimeters long. And of course, this is not drawn to scale. So let's say this side is 3 centimeters, and then this side is 5 centimeters. Well, the first thing when you're using Trigs is that you need to label your sides. So let's label our sides. Well, 5, that's the side opposite the right angle, so that's my hypotenuse. And then the other given side is the side that's opposite my angle of interest, so that would be my opposite side. So therefore, in my solution here, I will be using the ratio that has opposite and hypotenuse. And as you can see, that's sine. So using the ratio sine theta is equal to opposite over hypotenuse. And now I substitute my values in there. Well, theta is what I'm trying to find. So sine of theta is equal to the opposite. The opposite is 3 centimeters, and the hypotenuse is 5. So sine theta is equal to 3/5. And therefore, if sine theta is equal to 3/5, now with trigs, whenever you're finding the size of an angle, you need to use the inverse trig functions. So therefore, theta will be equal to sine inverse of 3/5. Now, at this point here, you could have actually, when you had 3/5, you could, and you know what, I'm going to do that. I'm going to divide it. Well, 3 divided by 5, which is 0.6, right? So then that means that sine theta is 0.6, and so theta is equal to sine inverse of 0.6. And then you check that on your calculator, make sure it is in degrees, right? And you take sine inverse of 0.6, and you will end up with 36.87 degrees, and this is taken to 2 decimal places.